Hello everyone. Hey guys. This is your JEE educator Megha, and today I am going to discuss with you what are quasi aromatic compounds. Okay. So yeah, the topic could be new to you, but yet it's very necessary for us to understand that what are aromatic and what is the difference between the quasi aromatic. Okay, we all know the aromatic compounds. I have also already discussed this thing. I discussed with you the aromatic compounds in one of my previous session, okay, where I discussed between the aromatic, anti-aromatic and the non-aromatic compounds. But right now I want you to individually focus over the quasi aromatic. So here, this is your JEE educator Megha, who is a CSI HEC net qualified with all India rank 25 in chemistry, is going to discuss with you all. So please stay tuned with me, and let's be ready to learn from here. Okay, so this is quasi. Okay, so to understand the quasi aromatic compounds, first we need to know that what are the aromatic compounds. Very small, very short, yet very important topic. Guys, if I take any of the species like this, or I take any of the species like this, okay, what is the difference between the two? Okay, so first of all, quasi aromatic compounds are ionic compounds. So first of all, they are ionic in nature. You need to know they are ionic in nature. Yes, absolutely. If I write it something like that, this is a benzene. This is a benzene. Okay, so these are the three molecules which I have taken for you, and we will compare between the three. So quasi-aromatic compounds are basically ionic in nature. So if I am talking about this, this and this, what is the difference that you could notice? You would say that, ma'am, here this is a benzene, which is a cyclic close ring, Other than that, here also we can see that there we will be having the delocalization of pi electron. Delocalization of pi electrons is already there. We do have a conjugated system. This electron will go there, this will go there, this will go there. There we have a complete delocalization of pi electron. There is a planarity. The ring is planar. And also this is obeying the 4n plus 2. That is, on putting n is equals to 1, we will be getting 6 pi electrons. So yes, this is also obeying the Huckel rule. So as per all that, you will say that, ma'am, it is aromatic. It is aromatic. But is this quasi-aromatic? No, this is aromatic but not quasi-aromatic. Not quasi-aromatic. Why this is not quasi-aromatic? Because first of all, quasi-aromatic compounds are ionic in nature. Okay, so now if there is an ion, it could be a positive ion or it could be a negative ion. Now let's see, in the case of the ionic species, whether they are quasi-aromatic or not. How to understand? Now guys, here if you would see in this particular molecule and in this particular molecule, what you notice is, yes, if I talk about this particular compound number 1, compound number 2 and the compound number 3. So in the compound number 1, we can see that this is a cyclic close ring. This is a cyclic close ring. The second point is, yes, it is planarity. Planarity is there. We can see that this carbon is also sp2, 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 sp2 hybridized. The third point, we do have a delocalization of pi electrons. Yes, there is a delocalization of pi electron. And here we can see that how many number of pi electrons are participating in delocalization. That is only 2 pi electrons. 4 pi electrons, not 2. Actually, they are 4 pi electrons. Okay. So if the 4 pi electrons are participating in delocalization, so what does this mean? This is obeying the 4n pi electron rule, and the 4n pi electron rule is for the anti-aromaticity. So this is anti-aromatic. This is anti-aromatic. So this compound can be quasi? No. Quasi-aromatic compounds are ionic in nature plus aromatic in nature. Okay. Now they are ionic as well as aromatic in nature. So this is ionic, but this is not aromatic. So this is not said to be quasi-aromatic. Understood? So this is anti-aromatic. It is ionic but not quasi-aromatic. Not quasi. There is no question of quasi-aromatic. If it is not even aromatic, there is no question of quasi. Now here if you would see the second molecule, what we can see here, is this an ionic compound? Yes, absolutely, this is an ionic compound. And when you will see here in this complete molecule, there we have a cyclic close ring. Yes, this is a cyclic close ring. The second point is there is a delocalization of pi electron. Delocalization of pi electron is also there. We can see that this pi bond and this negative charge is forming a conjugated system. They can undergo complete delocalization. The third point is here we do have a planarity, which is the condition required for a molecule to be aromatic, and the number of pi electrons participating in resonance are 4n plus 2. If you put n is equals to 1, that is 6 pi electrons are there. So if this is obeying the 4n plus 2 pi electron rule, that is a 6 pi electron, and all the points are getting obeyed. So what does this mean? This means that this is aromatic in nature. Now guys, this is aromatic plus ionic. So if this is a compound which is aromatic as well as ionic, is said to be quasi aromatic. Are you getting my point? So this is said to be quasi aromatic. Okay, now so what I just said is any of the compound which is ionic in nature and as well as aromatic in nature is said to be quasi aromatic. Now we do have one more question. Okay, now let me give you one more comparison. Okay, so let us have a comparison between okay, let me give you a very good comparison. So guys, this session is live. If you all are there, then please do let me know if you have any doubt. Okay, we can have a conversation. Now let me discuss with you the another example. Okay, so what I want to discuss with you, let's guys, I have taken two molecules. Okay, my molecules are this with a positive charge, or my question would be this with a positive charge. Okay, now let's see what happens in between the two molecules. Okay, if you would see this molecule, this is also ionic, this is also ionic, and if you would see, this is also ionic. Is it? Here also we have a positive charge, here also we have a positive charge. Both are ionic in nature. If you would see, you will find that they both are aromatic as well. This is aromatic and this is also aromatic. If you want to see, you can figure it out how they are aromatic. Here we can see that this is a closed cyclic ring. There is a delocalization of all these pi electrons within the ring, and the number of pi electrons participating in delocalization is 6 pi electrons. So 6 pi electrons is obeying the Huckel rule. Yes, it is aromatic. And if you would see in this particular molecule, here also this is a closed cyclic ring. Okay, yes, this is also a closed cyclic ring. There also we have a planarity. Every carbon is sp2 hybridized. The second point. The third point is here also we can see the delocalization of pi electrons. There is also a complete delocalization of pi electron, and this is also having the 6 pi electrons. So ultimately, because of the 6 pi electron, it is also obeying the Huckel rule. This is also aromatic. So this is ionic plus aromatic. This is ionic plus aromatic. So are they both quasi aromatic? The question is, are they both quasi aromatic? Think about it. Now the answer is no, they both are not quasi aromatic. This is not quasi aromatic, but yet this is. Why? Guys, quasi aromatic compounds are such compounds which are ionic plus aromatic, and the ion is a part of that aromaticity, is a part of that ring. Now see the difference. Here also we are having a positive charge. Okay, here also we are having a positive charge. This is also an aromatic ring. This is also an aromatic ring. But in this particular structure, is this positive charge a part of this aromaticity? So no. So the charge has to be a part. Charge has to undergo delocalization. undergo delocalization. Means whatever the charge, either the positive or the negative, whatever the charge you have, the charge has to undergo delocalization. Delocalization in a closed cyclic ring. In a closed cyclic ring. Are you getting my point? A charge has to undergo delocalization in a closed cyclic ring. Or in another words, I can say that a charge has to be a part of aromaticity. Charge has to be a part of aromaticity. Then only it is said to be quasi aromatic. It is said to be quasi aromatic. Now here, if you would see in these three questions, this is anti aromatic, no question of quasi aromatic. This was aromatic, this was aromatic, and this was aromatic. This was aromatic, but here there was no charge, so not quasi. And here it was aromatic plus ionic, and this charge is a part of that delocalization. This charge is a part of that aromaticity of the delocalization in a closed cyclic ring, and that's why this is said to be quasi aromatic. So what are the three conditions for a molecule to be quasi aromatic? It has to be ionic, it has to be aromatic, and the third point is the charge, whatever the ionic charge you have, has to be a part of aromaticity, has to be a part of aromaticity, or you can say part of delocalization. Is it clear? So if you can understand these 3 points, you will be able to understand the quasi aromatic compounds. Now the question is, why I am discussing with you the quasi aromatic compounds? Because the main rule, quasi aromatic compounds are much more stable. Quasi aromatic compounds are much more stable than whom? Compounds are more stable than aromatic compounds. More stable than aromatic compounds. Okay, so whenever there is a question of stability, please try to understand this compound is also aromatic, this compound is also aromatic, but this is quasi aromatic, but this is not quasi aromatic. So this compound is much more stable. This is more stable than the other. This is more stable and this is less stable. Many times what students do, students thinks that here we have a benzene ring, this is a benzenoid compound, and hence just after looking at the benzene ring they mark it more stable, but yet it is not. Okay, this is not stable. Here we know that this is the benzylic carbocation, but this benzylic carbocation and this quasi aromatic cation, in between the two, the quasi aromatic compound is much more stable. I hope this point is very clear to you. So I can give you many other examples for the quasi aromatic compounds. Okay, so the compounds, like if we have this as a negative charge, okay, or no, not this as a negative charge, as a positive charge, okay, or we could have any kind of species like this double bond and this negative. So this charge is a part of delocalization. This charge is also a part of this delocalization. Or I can take in another example which I have just took, that is let me do it again. This and this yet to be positive. Okay, so such compounds are quasi aromatic. So examples of quasi aromatic compounds, these are the very good examples where we are having a positive charge, and this positive charge, now see, this is a closed cyclic ring, they all are closed cyclic ring. Yes, absolutely. Is there a planarity? When we look for the planarity, this is a planar ring, this is also a planar ring. Negative charge if in delocalization is said to be planar. This will also get sp2 hybridized, and the carbocations are always sp2 hybridized. Yes, they all are planar. If you will look for the delocalization of pi electrons, yes, there we can see the conjugated system. There is a delocalization. This pi electron will move like this. This negative charge will go like this. This will go like this. This will go like this. Yes, there is a delocalization. And if you will see the Huckel rule, here we can see that we have a 2 pi electrons. Here we can have a 6 pi electrons, and here also we could have a 6 pi electrons. So ultimately we can see that they all are aromatic. They all are aromatic. They all are aromatic. This is also aromatic, and this is also aromatic. But out of all these, which are quasi aromatic, so they are ionic. They are ionic. This is also ionic. This is also ionic. This is also ionic. And at the same time, ionic, is this ion is a charge of this aromaticity? Yes. Is this charge, is this ion a part of this delocalization? Yes. So this is quasi aromatic. This is quasi aromatic. Here, is this negative charge is a part of this delocalization of the or this aromaticity? Yes, absolutely. So this is also quasi aromatic. And here, this positive charge is also a part of this delocalization? Absolutely. So this is also quasi aromatic. Okay, so such compounds which are quasi aromatic are more stable than even the aromatic compounds. Okay, so guys, I want to tell you one thing about the stability. The stability. So if you want to know the order of stability, stability order. Okay, stability order for all such effects, then please understand. First of all, there comes quasi aromatic. Quasi aromatic are much more stable. Then comes your aromatic compounds. Then comes your any such compounds who are having the electronic factor. If I need to say electronic factor, something like there is a back bonding or something is happening. If there is a back bonding, there is a back donation or something, electronic factor, electronic, okay, electrons, if they are doing any kind of synergetic effect or something, if there you can see any kind of synergetic effect. Okay, let me say uh, let me write it here, synergetic effect. Because of the electron density, you could have the synergetic effect, electronic effect or the synergetic effect. Then comes your resonance. Then because of the resonance, there would be the stability if you will compare the aromatic and any of the species which is resonance. Okay, so if I say if any of the structure is something like this, then here we can see that this is not aromatic, but yes, here is a resonance. So here we can have a resonance. So the any of the compounds which is having resonance, and then after comes your any of the compound which has the hyperconjugation, that is the more number of hyperconjugation, more will be the stability. Then you have to give the priority to the hyperconjugation, then you have to give the priority to the inductive effect, and then you have to give the priority to the anti-aromatic. So if you are looking for any of the compound with all such factors, this is the stability order. So this is going to help you a lot in everywhere whatever you study. So in major words we can say that this is A for aromatic, this is E for electronic, this is R for resonance, this is hyperconjugation, this is inductive. That is AERHI. Quasi aromatic compounds are much more stable, and the anti aromatic compounds are least stable. Okay, so if you are talking about this is a simple order. Aromatic compounds are more stable than any of the molecule which is showing the synergetic effect. I will tell you about this in my one of the another lecture. Then comes your resonance. If there is a resonance, that will be more stable with respect to the any of the structure which is showing more number of hyperconjugations than the inductive effect. So this is the order that you need to follow. This was the order that you need to follow whenever you are looking for the stability. Okay, anti-aromatic compounds are least stable, and the quasi-aromatic compounds are even more stable than the normal aromatic compounds. Okay, so this is it which I wanted to tell you about the quasi-aromatic compounds. Again, I summarize, they are ionic in nature, they are also aromatic in nature, but if you are looking for the ionic nature and the aromaticity, then the ion has to be a part of that aromaticity. So there must be a relation between the two. So if there is a relation between the two, ionic and aromatic, then only it is said to be the quasi-aromatic. So I think this is the best example which could help you to understand that why this is less stable than this. Okay, they both were aromatic, but this was more stable just because of the reason here the charge was a part of the ring. But here the charge, the delocalization is within this ring, but this charge is not a part of this ring. Okay, so that's the reason. Thank you so much, guys. I hope this session has helped you, and if you do have any doubt, please do let me know. I would be like highly glad to help you or clear any of your doubts if you have any. All good, guys? Okay, so this is it from my side. So if you want to know anything more, please do let me know in the chat section. You are free to ask any of the thing, bache. And we'll see you in one of my another lecture that will be on the electrophilicity and nucleophilicity, and we will also be focusing over the acidic and matlab I would like to say ki the difference between the basicity and nucleophilicity. Okay, we will also see the comparison. Is it true that whatever the molecule is more basic is going to be more nucleophilic or not? Okay, so be ready to learn through me. My all lectures are going to be in English, so I am targeting a specific audience, those who really want to learn through my lectures. You can also follow me on Unacademy Plus. There I am teaching many of the students, and 127,000 plus students are following my lectures, and they have dedicated so many of their heads. You just go through this particular section, you will get to know about the feedback that they have given to me. So thank you guys. If you really liked it, please like, subscribe and share, and thank you for joining me for my further session.